All right.
So, Aaron Abbott, LATICRETE International Senior Technical Product Manager. Aaron, a building materials industry veteran and Senior Technical Product Manager with LATICRETE International, is responsible for product development, training, and technical guidance. Over the last 2 decades, Aaron has specialized in self-leveling underlayments and flooring systems and has worked with architects, specifiers, contractors, and building owners across the country and internationally. He holds a BS in chemical engineering from the University of New Hampshire and an MBA from Bentley University. Aaron, thanks for making the time out of your busy schedule. We love having you here. I'll hand the screen over to you and you're off to the races.
All right, Chris, thank you very much for the introduction. And as always, very happy to participate with NFCA on education. You guys do a great job with this, and we're very happy to be part of it. So today we're going to be talking about the 7 deadly sins of flooring installation. And, you know, it's a snappy little title maybe, but there's a group of things that we just keep on doing that are insane. Let's be honest. As Einstein apparently didn't say, this is attributed to him, but I don't really think it was said by Einstein. Definition of an insanity is doing the same thing over and over and expecting different results. So there's so many things in life that we could categorize this way that we kind of know it's bad for us, but it's hard to break the cycle. So with floor covering installation and flooring in general, there's just this group of things that keep coming up. A lot of these things are easily or relatively easy to avoid, but for a whole bunch of interconnected reasons, we just keep doing them as an industry. So it's good to talk about these things. And even though you've heard about probably everything that I'm going to talk about before, we'll talk about them maybe in a little bit more of a linked way. But first, maybe it's good to start with talking about sanity. What does good look like for floor covering? Okay, so this is just, you know, what we would like to see as an industry when a flooring project is executed and completed. Just some examples. Obviously, the customer is king. The customer gets what they want. That's kind of the overall goal of everything we're doing. In that, the products should be durable. They should be properly installed. They should stick to the floor. In other words, they will remain adhered. Color is good. Warping is not present. They're flat, they're smooth, and they win the project wins the NFCA Installation of the Year award, which if there isn't one of those, there should be. So what is there one, Chris?
Well, we were talking about it. The board of directors were talking about it recently, and I think that will eventually happen sooner rather than later, hopefully. So yeah.
Yep. So it's fun. Okay, so that's what good looks like. What is good? What does bad look like? What can go wrong? Here's just a list of things that all of us on this webinar, I'm sure, have seen or heard about. Bond failure, right? Dimensional or shape change. Things, warp or move. The flooring doesn't stay flat. There's curling, shrinkage, expansion, blistering. You could get smells. You could get the smell of mildew. You could get maybe chemical smells from products that aren't supposed to be where we've put them. You can get things like cracking and splitting, premature wear, durability issues. The flooring doesn't last in the way that we expected it to, that we maybe, put our good money behind and hoped for. You could have esoteric things like slip resistance issues, efflorescence. You could have roller coaster hallways. Who has seen that? With sound attenuation, especially in residential settings, but also in commercial projects, the floor is too loud. Maybe people below can hear, boot steps up top. The floor isn't warm enough. It's too cold for radiant systems. It can be hollow, creaky, spongy, too hard. And of course, the worst thing that can happen is you don't win the NFCA Installation of the Year award, which will be beginning shortly, I guess. So if we
I got,
type, go
yeah, I've
ahead.
got a few to add to that. One would be you won't get paid. Another would be you'll lose a good customer, and three, you'll go broke trying to afford your shrink bills.
So true about, the lose the good customer. And that's not just a one-time thing. It might be lose that customer forever, right? It's so easy to lose a customer and it's so hard to build a reputation, but you don't have to do too many things incorrectly to lose them for a good long time. So good point. So you know, taking a look at like all the things that can go wrong, one way to maybe attack these problems is to try to categorize them. As human beings, we like to put things in groups or categories. So I'm not going to go through this in detail here, it's an eye chart, but if you look at the types of failures going down the list: adhesive failures, curling, shrinkage, expansion, discoloration, and then causes, some of the primary causes of each of these things: moisture, acclimation of the floor goods, substrate flatness, deflection of the substrate or deflection of the materials, or a weak substrate. And you start to click, check off which of these failure modes is associated with which major causes. Patterns emerge, and you start to see some of the interactions between these causes as well. So, for example, acclimation. You buy expensive, say a rubber sheet good for a medical lab, and acclimation, very important. It's one of these things. And what is that dependent on? It's dependent on the temperature and humidity and time of acclimation. So that said, here's a proposed list of 7 deadly sins that we all have to deal with, that we all could, if we understand them a little bit more and think about them, I think we could avoid. And this is not a list that is mutually exclusive. There are interactions here between these different sins. And I'll propose it as a list, not the list. So there's other things that arguably could be included here, but let's go with these today, because these certainly are things that I think we all see. So the first 3 are moisture related, and then the next 2 are substrate prep related, and then there's a couple additional ones at the bottom we'll talk about. So not reading and understanding manufacturers' moisture requirements. This is purely, this one's maybe the easiest one here. This is reading and understanding. This information is available. Understand what the moisture requirements are for the flooring installation. Okay. Number 2, once we know what's required, one sin that definitely happens all the time is we don't analyze it sufficiently. Okay. So we'll talk about that. And once we've analyzed it, number 3, not reacting to the moisture conditions that have just been categorized and analyzed well. Now we have to react well to that. Number 4, not flattening the substrate sufficiently. This is of critical importance, and it becomes an issue very frequently. Not cleaning or preparing the substrate properly, not selecting the right installation products. And lastly, this sort of is related to all of this stuff, not staying educated. And again, we'll get into this. There's so many resources available, and we'll talk about them. So let's dive into sin number 1, not reading and understanding manufacturers' moisture requirements for flooring installation. So who are we talking about? Whose documents are we supposed to be reading here? Well, the manufacturers include the adhesive manufacturer, the floor goods itself, the self-leveling or patch and skim, sort of the prep products underneath, and moisture mitigation products. Okay, so all of these manufacturers are involved, and there's others too. But these guys, all of these manufacturers, they publish well thought out documentation in most cases, and read it and understand it. See how it all works together. So, for example, say we're putting down sheet flooring. I have an example here from a very well-known and respected sheet goods manufacturer, Tarkett. Where can we find their requirements regarding moisture? Well, it's on the product data sheet. There's also information that could be on a technical data sheet, which might be something separate. An installation guideline, some of these companies call these installation guidelines, or referenced standards. So these are standards like from ASTM or other standard organizations that publish standards that are referenced. So for example, on this sheet for sheet flooring, there is a small section about handling and storage. It's sort of acclimation, and they talk about storing, protect the floor goods from the elements, and maintain the temperature within a certain range and the relative humidity within a certain range. And then they talk about, if you're installing this on concrete subfloors, test for moisture, and they tell you how to do that. They tell you specifically about a couple standard test methods, referencing ASTM F1869 and a couple other things here. So this is where you find these things. Okay. Now, if you're doing self-leveling and you happen to be buying, or patching, and you happen to be buying the product from LATICRETE, you would refer yourself to our document called TDS 230. This is a substrate preparation guidance document and how to use our primers. And it's just an example. Our competitors all have documents like this. And this particular one, we say, conduct moisture testing, essentially, not just for our products, which are very tolerant to up to 100% relative humidity without pooling water, but we say specifically, however, you can install up to 100% relative humidity. However, concrete slabs may not be dry enough to meet the moisture conditions required for the finished flooring. So even though our stuff can go down, other products that are going to be involved in this project, you need to read their moisture guidelines. So we say test concrete slabs for moisture conditions in accordance with the finished flooring manufacturer's specs prior to installing self-leveling products. It's very important, so we know our stuff is being used with floor goods, glues, maybe from different manufacturers. Read it all, read it up front, understand it.
Aaron, a couple of ironies here. Probably the least represented segment of the market on a education session like this is the installer, him or herself. It's the manager that will be here, and the manager has to take this information and convey it to the guy or girl who's got the boots on the ground. And in some cases, the installer is an immigrant. English will be a second or maybe even a third language, and so they're challenged to read this small print. A lot of deference to YouTube. YouTube's a very useful resource for getting the message across, but there's all sorts of pressure points when it comes to following these guidelines. A, understanding them, but B, then the second point I want to make is following them means you've got to push back against your customer, the GC. The GC is going to say, don't delay me. I don't want you reading this small print if it's going to delay me. So if you do delay me, I won't pay you. So you figure it out. And one of the arguments I encourage, you can push back against that. It's not me, the installer or the dealer, that chose the product. I'm here putting in the product that you specified, architect, and you bid on, general contractor. So I'm not being difficult. I'm just trying to put down the product you brought to the table properly. So what you're telling me to do it wrong just doesn't make sense.
Great points. And the good news is that I'm at least personally seeing more pre-project planning meetings, these early meetings where I've sat in 2 or 3 of these just within the last month with projects, large projects, in the Northeast of the United States, just where they happen to be, that the general contractor is bringing in all of the flooring trades and the concrete people to say, let's talk, and let's talk about what is required, and the floor goods. So you get concrete, you have the substrate preparation, patching, self-leveling people, you have the floor covering people, including the contractors. And at one of the meetings I was just at, the floor covering manufacturer and the glue manufacturer all sitting at the same table and the concrete hasn't even been poured yet in this happens to be a hospital, the one I'm thinking of right now. So these conversations are starting to happen more and more, and you're absolutely right. Bring it in. The people that have to understand this stuff aren't only, I mean, ultimately it's the contractor who's installing, and you're right about language and where they get their information, but it's the coordination of all this up front that really is the biggest bang for your buck. So
yeah, great points.
So okay, so we talked about reading and understanding stuff. That's really easy, right? Okay, sin number 2 is not analyzing the moisture situation sufficiently. So we know that moisture can be a problem. The manufacturers are telling us. Now we have to analyze it. They're saying, they're giving you a target, you got to be below this usually. So what are the most common methods that are referenced if you read all those manufacturers' instructions? So they're going to be things like ASTM F1869, that's the calcium chloride test. That one's sort of been losing favor over the last 10 or more years. ASTM F2170, that's the in situ relative humidity test. That's drill a hole, put a probe in, test for humidity inside the concrete. And ASTM F2659 electronic moisture meter test. So these are things, this one's not referenced that much, but it's starting to be talked about more.
I'd just like to make a comment about calcium chloride, which gets quite the bashing these days. It's still a very relevant test, and it does things that the RH test, for example, cannot do. For a floor coverer, it actually determines what's happening at the surface in terms of vapor emissions. And so while you're troweling out adhesive and you want that adhesive, they've got that critical window of curing that happens over 24 hours, maybe it's 36, maybe it's 72, maybe it's 5 days. Once your adhesive is cured, most of the problems that come with putting down new adhesive will go away. If it's not allowed to cure because you've got vapor coming out of the surface of the concrete, you're going to have a bond failure. And the calcium chloride test will tell you that, whereas the RH test will not.
You're absolutely right, Chris. The calcium chloride test, it does have some issues with sort of, maybe we're not measuring the water coming 100% from the concrete. It might be leaking in from other places, but it's a really simple, in theory, a really simple test. The calcium chloride pellets, they absorb humidity, they absorb water vapor. So the theory here is if you have a weighed up little cup of these things and you seal it down onto a concrete floor that is prepared the way that the actual floor will be prepared for when the floor covering is going down, you weigh this thing before and after, wait 72 hours, and you can basically tell how much water vapor is coming up out of the concrete. So it's a flux type measurement, how much is fluxing through that plane surface of the concrete. And this used to be very popular. It's still referenced quite a bit, but it's maybe on the decline. Not sure if that's right or not, that it's on the decline, but it seems to be in the literature. The most popular method for measuring and also the most popular sort of way to set limits for installing your floor goods is the RH test. So this is F2170. You drill a hole in the concrete, you put in a probe, and again, you measure relative humidity, which is on a 0 to 100% scale. And this is sort of something that came into favor because it's supposed to take into consideration down below the surface what's actually happening at a certain depth in the concrete. So that's referenced a lot. And I won't talk about pros and cons of these things necessarily. The third thing that's coming in to more discussions now is the electronic moisture meter. It's basically a set of probes that are part of this device, and they measure electrical resistance. The more water, the less resistance. And so that creates the ability for the electronic device to give you a reading, a numerical reading that tells you, relatively speaking, how much moisture is in different spots. The big pro on this one is you don't have to drill any holes, and you don't have to wait 72 hours. In fact, it's an immediate reading. You place the device on the surface and you immediately get a reading. It has its downsides. It's maybe not as sensitive in some ways. It's more of a comparative method, but it can definitely show you hot spots on a floor, and it can definitely give you a sense of, do I have maybe a problem where there was leaks over here in this area? And it might be useful to, if you think your floor is completely, dry, that you might be able to find certain areas that are of some concern. So those are some of the methods to measure.
I mean,
now, yeah, go ahead, Chris.
Sorry, because it's topical just to say it, but this indicator electronic meter test will bring something to the table that the other tests won't do, which is very interesting for floor covers. If you are faced with what we call dew point, another way of saying dew point would be condensation point. You have a humid, wet building site, trades working hard, sweating, breathing heavily, lots of moisture in the air. Maybe you have 20 degrees Celsius, around 70 Fahrenheit or so in the air, but your slab is at 5 degrees. You're facing a dew point problem. And so what happens then is you get this invisible layer of dew or condensation forming on the surface of the concrete. It immediately sinks into the concrete. You don't see it. And the only fail-safe is this device right here. If you trowel out adhesive on that surface that's been subject to dew or condensation point, you're going to have a failure. This device is part of trade scope of work for a floor covering installer. It's your job under trade practice to execute this test. Just drop an indicator test on the slab prior to troweling out your adhesive, and just one last fail-safe. If you don't do it, you're not doing your job.
Yeah, good point. All right, so we talked about, reading instructions to find out what the acceptable limits of moisture are. We talked a little, survey sense about how would you measure those moisture conditions. And now we get on to sin number 3, which is reacting. Okay, so we know what the target is. We know how to measure it. Now, how do we respond to the moisture conditions that we're sensing? So it's important, to maybe step back and think about where moisture comes from. We want to install good floors. We want them to be durable. We want them to last. And we know that moisture can be a big problem, right? You can't pick up an industry journal without bumping into a couple articles about moisture, in concrete and flooring problems. So it's good to think about, where does moisture come from? I mean, we live on a wet planet. There's what is it? 2/3 of it are ocean, and it rains, and in construction, your buildings are open, etc. So just good to review some of the sources of moisture. So moisture comes in, water is used to mix with concrete. So that's kind of a big number one. Weather during construction. So when the building is wide open, there's a lot of rain, there could be snow, there's going to be extra water even after the concrete is placed. You have groundwater concerns. You have atmospheric equilibrium. If you're installing concrete in Hawaii, where it's very humid, versus Arizona, where it's very dry, there's two different situations there. Obviously you can have over time leaks, plumbing leaks, cleaning, and other temporary sources of moisture. So, concrete floors, it's basically a mixture of rock and sand and cement, some admixtures. There's a little bit of air in concrete and a bunch of water. And when we're mixing concrete and placing concrete, we're intentionally putting in more water than the cement and admixtures, the stuff that actually sort of dissolves and disperses in water, then those things need to chemically react. So the extra water is needed because we want the concrete to flow out. If we didn't have that extra water, the concrete wouldn't flow out to the forms. Now, there's things you can do to reduce the amount of water you need, but there's almost always going to be extra water than what's required chemically. And that extra water has to go somewhere after the concrete cures, and it takes time. What affects the drying rate? So temperature and relative humidity of the overall system, the atmosphere and the concrete, and those deltas. That little triangle means delta. That means the change in temperature, the temperature differential between the concrete and what's below and the outside air. Very important. The relative humidity differential. If you have, say a kitchen sponge that's completely saturated, right, and you put it on your counter next to your kitchen sink, that's going to be at, oversaturated with water. And if you're drying that kitchen sponge in a room that is 100% relative humidity, it's going to take forever. If you have it at room temperature and 50% humidity in the air, that kitchen sponge is going to dry out and lose its water much faster. And if you're in the desert and it's 100 degrees Fahrenheit and it's you have low humidity, that sponge is going to dry out right away. So the same thing is true with concrete. Concrete is kind of like a sponge, and it's going to absorb and emit water vapor over time based on those driving forces of temperature and relative humidity differential. But also keep in mind there can be new sources, like we talked about, rain, leaks, etc.
Another driving force would be HVAC, like
yes.
we were talking about earlier, right?
Yeah, HVAC, absolutely. I mean, that's how you create the differentials, right? You turn your dehumidification system on, your temperature system on, you dry out the surrounding air, and you'll speed up the driving force that allows that moisture to evaporate from the concrete.
Yeah, which makes room for the manufacturer's warranty, because you've now dried your concrete because you've got your HVAC on. Now everybody's happy.
Yep. Another thing is the surface condition of the concrete itself. So if you finish the concrete to be very, like hard trowel finished or burnished even, or there's curing compounds on the surface or carbonation, there's several things that can happen to that surface of the concrete that basically seal in the moisture. Some of them are intentional, right? I mean, with curing compounds, the whole purpose of a curing compound is to hold the moisture in the concrete so that it's there long enough to build up, the properties of the concrete that you want, to allow the hydration to occur. You'd usually use these in cases where you're afraid that you're going to lose your moisture too fast, so you put curing compounds down. But that surface finish, one quick and easy test that's referenced by several manufacturers is a water drop test. There's actually an ASTM method for this now, but you put a droplet of water on the concrete, and if it looks like this photo, you got basically olive oil in a Teflon frying pan. There's no absorption. It's not absorbing into the concrete quickly. That is a sign that there may be a curing compound or some other surface effect that is preventing absorption of water down into the concrete, which probably means that if you were to remove this layer, right, like what you're going to do right before you install floor covering, you maybe sand the surface or shot blast the surface. Suddenly you've taken this impervious blanket off, or layer off the top of the concrete, and now it's going to be blossoming with moisture vapor emissions, which are going to be very high, at least temporarily. So that's sort of like water from the top. How about water from the ground, water coming up from below?
Aaron, can I just ask you to step back 1 second and just talk about the opposite to a non-porous?
Yes.
Let's say if you shot blast off that tight impervious surface, and now you're left with very porous underneath for whatever reason, what happens to your adhesive?
Great point. So the adhesive manufacturers, they deal with this in their instructions, and that kind of goes back to sin number 1, reading and understanding instructions. Read what they're saying about absorptivity, and they are calling out for the use of water drop tests and other absorptivity tests, because if you do have that case that you just talked about, Chris, where the water gets sucked down immediately, it just goes right down, what's going to happen to your water-based adhesive? The same thing. It's going to suck all the water out of the adhesive, and the adhesive's not going to work right. So you either have to prime it or put on, you have to do some other preparation step. So absolutely important to understand that, the other side of that too. So water in the ground, if below a foundation, well, hey, there's supposed to be a vapor barrier or a vapor mitigation sheet down below. It's sort of standard practice. These things are notorious for tearing, right? Even during installation, they're notorious for tearing. And these photos are from a hospital project that the sub basement was 18 feet below the river next door. And they were installing expensive equipment down there. So, they went to the trouble, and they were getting some water coming up. So they went to the trouble of cutting away the foundation, actually, the slab, and checking and inspecting their vapor barrier. How many people are going to do this for a renovation? Not too many. But if it's critical, maybe you should. And these are things that you can fix. But water can come up from below. It's it's one of those classic things. Understand where your sources are and what your options are. It's much easier to, they call this type of moisture protection, the sheet underneath, they call that negative side protection. It's much easier to keep the water out from, coming from the ground up into the concrete if you have a sheet below than if you try to treat the top of the concrete. So, if you do have the ability to check your vapor barrier, make sure that sheet underneath the slab is doing what it's supposed to do, you can do that. I know that this one's incredibly difficult and costly to actually check.
I love that picture on the right. That's so telltale. I was listening to a seminar on a guy that was talking about concrete, and he said that you mentioned earlier, when the concrete truck arrives on site, you got to get that cement out of the truck, and the only way to do it is to put more water in it when you're generating your original mix, so that you can actually get the cement product out of the truck. And because now you've got a lot of moisture or water in that cement mix that you want to get rid of, otherwise your slab's never going to dry. I heard that a common practice for builders is to puncture the vapor barrier with a piece of rebar or whatever, just like you're seeing in that picture on the right, so that the excess water drains out into the ground. And then you pour your slab and
it's I mean, really what that comes down to is communication about, like, why is this plastic sheet there? Everybody needs to kind of know.
And never assume that it's intact. You can't prove it. So just assume it's not intact.
Right. So timelines are also, project timelines. When you're building a hospital or, any project, there's going to be a Gantt chart. There's going to be sort of a timeline to what's happening. And in terms of moisture, and we were talking about drying, so just, moisture in concrete, being aware of factors like, okay, after the concrete has gone down, how much time is available before the floor covering goes down, but also before, when the HVAC system is coming on, when the if there was a curing compound on the concrete, when is that happening? How do all of these activities line up, and how are they sequenced? And I'll get back to this in another sin here. But okay, so what if we have a lot of moisture in the concrete slab, but we really need to keep the project moving forward, and we got to get that floor covering down. So there's moisture. What are your options? There's really three major options. You can wait until the concrete dries, and that kind of goes back to the timeline. You may have the time in some cases to clean up the concrete floor, allow that slab to dry. And I mean, it's not totally crazy to expect that the concrete in a large building might have been placed a year or two ago, right? If the conditions are right, maybe that is enough time to evaporate all the water that you need to get out of there to put your floor covering down. So that's a possibility. You can wait, you can heat and dehumidify, you can retest if you want to, and sort of chart progress until you're going for, say, 80% relative humidity. Well, we can see we're on the march, and we can project, that we might be okay in a month or two. And there's also continuous monitoring and data logging equipment available now that allows you to put your probes in the floor and measure humidity. And those probes talk to a little Wi-Fi or cellular hub that then you can go on your iPhone and see, section A12 of my hospital wing is now approaching dry enough so I can go deploy my floor covering people. So another option is you could choose a different flooring system. Hey, we're ready to go. This flooring system, including the adhesive, is very intolerant to high moisture. Maybe there is flooring or glues that are more tolerant. So that's another option to consider. Or you can mitigate. And the photos here are of a two-part moisture mitigation epoxy type system, which can be placed over shot blasted concrete. And that creates a really good barrier to, or, it retards the amount of moisture that's coming up from the concrete and can protect your floor goods. If you're considering something like that, these epoxies, the ASTM F3010 standard is sort of the standard practice for two-component membrane forming moisture mitigation systems. So these are used a lot on projects where the timeline requires the floor goods to be installed before the concrete is going to be dry enough. So you can put this down, and that's going to knock down that emission of water vapor down to a safe level.
I just want to add that under trade scope of work for the ticketed trade of floor covering installer, this practice is not in our scope. You can take it on as an extra contract if you want, but that is concrete trade business. So once you do take it on, you're entering the world of the concrete trade.
So with moisture mitigation systems, such as the two-part moisture or two-part epoxy type systems, keep in mind compatibility between and warranty between the different layers, because there's certain glues that would not be appropriate to go directly over an epoxy layer. You'd have to put something else in between. So keep that in mind. Floor preparation, for epoxies, you really have to have a super clean concrete floor, and the surface has to be strong enough. You got to mix these things very carefully, make sure that there's no bubbles, because each bubble could be a fisheye where that could be a point where moisture could come out. And measure your film thickness. So those are sort of the moisture related sins. Sin number 4 is not flattening the substrate. So modern flooring, everything that we're seeing these days, its quality is going to be highly dependent on the substrate, the subfloor flatness and smoothness. And it's difficult to make concrete flat, especially when you're running in elevated, onto decks, and you're pumping onto elevated decks that can settle over time. But even concrete on grade on the ground can settle and curl potentially and change its flatness. So flatness can change over time. Deflection isn't always perfectly predictable. And there's a question of who is responsible for flatness. But first of all, what are the requirements of flatness for the floor goods? So ASTM F710 is the resilient floor covering installation standard. You can review that. That has some statements about acceptable flatness levels. Manufacturers of the floor goods and the glues, they'll also sometimes be talking very carefully about flatness and surface smoothness. Industry group recommendations, and architect specs. The architect is supposed to take all of this input and sort of summarize it into a spec. But with new concrete, you may be pouring a new concrete slab and finding out that when it's time to install the floor goods, even though that concrete contractor they did everything that they were supposed to do. They measured their floor flatness, their FF measurements, and they passed, at the 72-hour mark. Well, now a year later, when it's time to install, suddenly, we put down this is a photo of a partially self-leveled section next to so that the darker layer closer to the camera here is the concrete, and
great photo.
the layer in the background is the self-leveler, much flatter.
Great photo. I love it.
Yeah, so you can see it looks, maybe without that other layer there, you wouldn't be able to detect it, but that's something that has to be flattened. Very briefly on this, I'm not going to get into detail here, but the two sort of competing divisions here that we're talking about, Division 3, which is the concrete side of the tracks, and Division 9, which is the floor covering side, we're measuring using different measuring devices and different measurement systems. Concrete people use F numbers. This is measured usually using a device that sort of not scans, but it rolls over the surface and comes up with an F number, okay? And people that are installing floor goods, they're usually using something like a straight edge, a 10-foot straight edge, and they're looking for gaps that are smaller than 3/16 of an inch in 10. And sorry for my American measurements. I know that metric would be better for NFCA, but so those are the two things. And what's good enough in one project, you got one project manual for a whole new hospital, and you've got Division 3 being measured in F numbers and Division 9 being measured by straight edges. What could go wrong, right? So why, again, just another reason why flatness is so important. How many, of us have been seeing more and more large format tile? Here's a gigantic tile that's being laid down onto thin set. Do you think that gaps underneath this, sort of those gaps under a 10-foot straight edge would be good for that tile? No, and is the thin set the best way to fill the gaps that might be there? Maybe
just double up on your back buttery.
That's right. Yep. Use more butter. So, there is no real correlation, to be honest, between FF and gap in 10, so to speak, straight edge measurements. But the types of numbers that you'll see in a lot of projects, in the division, and this is like for one project, you'll see the concrete needs to be put down at an FF of 25, maybe. But then you read more in the same project manual, you get down to the Division 9, the exciting sections, and you find that the floor goods require 1/8 in 10. So there, one project, two differences. And maybe in bad situations, nobody kind of made this leap of faith, and they're thinking that, well, if you passed the concrete passed at FF 25, you're going to be able to install your floor goods without any extra money set aside for fixing that problem. So there's organizations like the American Society of Concrete Contractors who publish position statements like this one, which is basically meant to sort of protect the interests of the concrete people and get everybody to communicate, so that we're reducing problems. And in this one, they have this ASCC position statement number 6, which basically says that what we were just talking about, Division 3 concrete specs, they measure and they specify quality through FF measurements. And Division 9 flooring specs, they use a measurement gauge of a straight edge usually. And what ASCC is just saying here is that, hey, we're suggesting because of this, that the owner, the builder, provides a bid allowance that, allows for the strong possibility that this gap will have to be bridged and we'll have to fix some of the flatness.
Aaron, you were on the committee, NFCA committee, that addressed this problem and why there is this gap between Div 3 and Div 9. And that committee, after 16 months, identified what the gap actually is. And it's ambiguous specifications, incorrect or incomplete language issued by the architect or consultant that does not connect the concrete trade to the flooring trade. And so with your help and all the others on that 14-strong committee over about 16 months, we issued a new specification that dealt with this so that any architect around the world can pick it up off of our website as a free download. And so I just we just had a major builder up here in Canada take this on and stated to the author of our spec, that concrete placement spec, that we will be adopting this. Fantastic news for floor covers. Oh my God. Now that allows me to get on the phone and call all the other builders and say, hey, leaders are leading. Where are you in this game? Are you going to adopt this too? And if not, why not?
Yeah, this is big. It's huge. And NFCA is an absolute leader in getting the word out on this. And, you know, I was proud to be on that committee. And I think that the outcome is very useful. Chris, this is avoidable. This confusion is avoidable. And even for the GC, they benefit if they are aware of it. And for example, if on the Gantt chart on the top of this, if we think about, there's like this the red section of time, the change order process. Okay, so this is like a project where we didn't think ahead of time that we might need to put money aside to self-level or patch or fix that inevitable flatness problem with the concrete. Or you could be proactive, the Gantt chart on the bottom, where we did something proactively. In this case, maybe put self-leveling underlayment into the project up front, because we know that this thing is going to happen every time. But instead of having to point fingers at the last minute, right when the floor covering trades are coming in, and finding that there's a bigger problem with flatness than we all thought, this is how to save time, and time is money. So you can accelerate these projects. Okay. Sin number 5, very basic one, but it happens all the time. We don't clean or prepare the substrate properly. So we go into, this happens a lot more in renovations, but even in new construction. We got to make sure that concrete is free of contaminants, period. Okay. And there's a whole bunch of different things that can be on that floor, but you want to clean that. You'll read the requirements for this cleaning in again the documents that the self-leveling manufacturer publishes, or the floor glue manufacturer talks about too. Cleaning is important. Glue sticks to whatever's right below it, right? But it may be a weak layer. So that's kind of the point here. So the photo here, shot blasting, very common for a project where the concrete needs to be opened up. You need to make sure that you're going to have a good, you don't want a latenance layer on top. There's all sorts of different equipment that can be used. There's mechanical abrasion, which shot blasting is one of them, but grinding sometimes works. Even scraping or chipping old residues off, it can be used. Hydrojets. I put acid etching and chemical cleaning on this list with a question mark, just because most of the time that's not a good method. It's something to be very careful with.
Hey, Aaron, I've been slowing you down, but just note on time.
Yep. Yeah. Sounds good. Okay, so a couple other things to keep in mind. There's, again, the manufacturers are going to be talking about the different tests, but tensile bond strength tests may be called out to before you've installed your floor goods, to make sure that surface is strong enough to hold the glue down. So that's something to keep in mind. So that's sin number 5. And quickly, sin number 6, selecting the right installation products. The point here is that the concrete and maybe moisture mitigation systems on top, patches and levelers, and then the glue, and then the floor goods, all of these things have to stack up one on top of each other. And keep in mind that the manufacturers of each layer may say that, hey, we're compatible with product type A, but not necessarily product type B. So the compatibility between the layers is also something that can cause us harm. And lastly, to sin number 7, which is super easy to avoid, but that sin is not staying educated. So how do you avoid not staying educated? You take advantage of all of the industry organizations that are offering continuing education programs, for everybody that's involved. And Chris, you brought up earlier that the people that are involved in sort of installing floors, everybody from the actual laborer to the supervisor to the general contractor to the planners, the project managers, the architect, the building owner, industry organizations. There's so many different resources available. NFCA, in Canada, what a great group with all the specifications and the reference manual that's out there and all the stuff that Chris was talking about earlier. In the United States and for North America, there's FCICA, there's the Tile Council of North America, there's a wood, there's people all over the place that have checked these things out, stay educated, set aside time, every season at least. And I work for a building materials manufacturer in LATICRETE. We have reps all over the United States and Canada. We are more than willing to do product demos, how-tos. These are in-person type things, but we also have videos. We also have YouTube, resources out there. We have something called LATICRETE University, and our competitors have this stuff too. So it's not like you can't go out and find resources to better your skill set. So those are a list of 7 deadly sins, and I thank you for listening. And hopefully with just periodic, kind of going back to basics and thinking about, not just everything that can go wrong, but the things that can go our that happen frequently and also are avoidable. This is like the low hanging fruit for our industry. It's so I like that saying. It's such low hanging fruit. We're going to call it watermelons, right? So anyway, we got some watermelons to pick here.
Excellent, love it. And I've always said the mark of a good company is the technical support that it offers up, just as part of the service and part of the product. If you're buying self-leveling compounds or adhesives with no technical support or without knowing who might come and answer the questions, don't do it. Change your mind. Find a product that represents itself out there. And LATICRETE is one of them. In fact, all of our national education leaders are that way. It's just cultural. It's built into the culture of the company, I think. Maybe it's like it's as above, so below. It drip feeds down, but it's great to have that support. And Aaron, your product category is so challenged. All of the problems are mixed up with what your product tries to do, which is bond the concrete poured in January to the flooring installed in December. It's and I've sat in front of technical guys. I've learned more from technical guys who and girls who explain their product and what you need for prep at seminars than any other source of education. You have to know your stuff if you're going to sell this product and have it work. And boy, the stakes are high. 100,000 square feet of half-inch thick underlayment, and it fails. And wow, like you're going to go broke real fast.
Yeah, and along those lines, we have a document that talks about, it's a guidance document for substrate prep and primer use, okay, for our self-levelers primarily. And, it's an 8-page document. Okay, so yeah, fine print, and it looks like, we'll talk to some customers or some contractors who sometimes will say that's a lot of information. And what's true though is that everything in there is based on experience. It's based on, okay, well, we had problems in the past and what caused those problems. So we're going to avoid doing those things. We're not going to keep doing, that definition of insanity, right? Keep doing the things that cause you problems over and over again. We try to avoid that insanity. We try to, put it in it. And LATICRETE is, as you mentioned, is one of, several manufacturers in this industry that We really, our number one goal is to make sure that the products are used successfully, and that the end result for all involved, that the floor works, that the owner is delighted with the floor. That's the goal. That's the reason that we're doing this.
I like what you said there, that your installation guidelines are relative to real life scenarios, and every day something new happens, and it means that your document is going to expand now by one more line and one more item. We were exactly the same. Like, I worked for a firm years ago. It was all about high end. We were not interested in mid market or low market. We were going to do it once, and we were going to do it right. And our terms and conditions document started out at about a half page long to a page and a half. And one of the items was homeowner must sign, or client must sign, this box that means they have read these terms and conditions, understand them, and agree to them. And every time something went wrong, that was process oriented, that would everyone would benefit by having a line item in those terms and conditions to avoid that happening again, it went in, and hence that document grew and grew and grew and grew. It was like the best thing we ever did, because people read, homeowners and clients alike, whether it's commercial or residential, they appreciate being told this could happen. They get a chance now to say, no, I don't want to go down that avenue then, if that's possible. If you don't give them that choice and they end up going down that avenue they hate, they're going to beat you up and not pay you. So transparency is really powerful.
Yep. Communication, transparency, connecting the different players or the different stakeholders, all together. I mean, let's face it, a good high quality floor is expensive. It really is. I mean, these are not cheap materials, and to get it to, we ask a lot of our flooring, right? We get people walking on it, you got wheels, you get, cleaning, for that floor to last, you got to do everything right underneath. So, these are the types of things that we all should be thinking about.
All right, we just have about 2 minutes left. I just want to make sure that if anyone has any questions, they have an opportunity to ask them.
Yeah, I'll read out this one from Clayton. He makes an observation about RH probes. Clayton Schull, RH probe / sensor manufacturers state their probes are not accurate for measurements over 90% RH in situ. And also, how can you then measure RH at 100% when the probes only display up to 99%? So how useful is measuring static vapor deep inside a slab when it is far from the bond layer? So he's raising questions about the validity of the RH test there.
Yeah, there's definitely, I'm not sure about the sensor manufacturer that's being referenced here, in particular about the 90 plus not being accurate.
I don't think that's a general across the board, right? It's that maybe specific to one or two, maybe, I don't know.
It must be specific to one or two, because I know that the floor covering adhesive manufacturers, I mean, they will differentiate. For example, there's certain brands. LATICRETE doesn't make floor glues currently, but I know that what's available out there, they differentiate themselves. Some glues will require 80% relative humidity or less. Some are 90, some are 93, 95. I've heard 97. So that 90 to 100 range and being able to differentiate is important. And I think there's RH probes that are able to make that difference. But you're right. Once you get up above 99%, you're talking about 100%. Essentially, from my opinion is that if you have a floor good of any kind, or a self-leveling that can be installed up to, if we're saying we can install up to 100% relative humidity, what that really means is that it's moisture tolerant, and as long, in general, you can't install anything over a pool of water. So if you have, you know, a layer of condensation or a pool, you know, puddles of water, you can't install over that, of course. But when we say 100%, what we mean is that as long as that surface is free of liquid water, you can install it. So it means it really doesn't matter up to that point. But, you know, as you get closer and closer to 100%, you run the risk of condensation, which means a layer of liquid water. So, Chris, I think you had brought up dew point and measuring that, and that could be a whole 1 hour, you know, webinar on just how to measure moisture near the surface and dew point in more detail.
Yeah. Well, I mean, one last comment, maybe. NFCA's put together a committee called A11, moisture testing, a review of moisture testing, a review of the three major or main test types. That would be the RH test, the calcium chloride test, and the electrical impedance test, just to sort of explain what they are, how they work, what they're trying to achieve. And we've got 40 manufacturers around the table right now. And if you're a manufacturer out there listening to this, we invite you to come to the table, be part of this discussion. We're going to be issuing a draft copy of a best practice for moisture testing in the coming months. And we want all manufacturers to feel like they understand where that's coming from, why it's coming at all, and get a chance to critique it and bring back questions and help to shape it so that it suits your organizations. So a public invitation to join that committee. All you got to do is reach out to us at NFCA and you'll be in. And we can have thousands because of Zoom. And that's what we want, everybody to have a seat at the table.
Yeah, that's been a great committee so far, Chris. So just
good stuff. Well, I think, Aaron, we picked your brains and we've enjoyed listening to you. I think that was a great presentation. I love the photographs and the information is so apt, and we need to just repeat.